Welcome to today's presentation, Greater Developer Flexibility with NoSQL in EDB Postgres. My name is Sandra Vicky and I'm Director Product Marketing here at Enterprise DB. I will be joined by my colleague Mark Linster, Senior Vice President Products. NoSQL is a technology that has been talked about a lot in the recent past, especially for web, mobile or IoT applications. It is a great technology and we would like to show you how you can leverage the benefits with EDB Postgres. Today's presentation will cover the EDB Postgres platform, the NoSQL topic itself, what is NoSQL, and what are the pros and cons. We will look at the benefits of doing NoSQL with EDB Postgres, and we will also look into how you can integrate other NoSQL technologies with EDB Postgres. We will then have Mark Linster to give us a demo of the NoSQL functionalities, and I will finally summarize the presentation today and provide you some resources. Before looking into NoSQL in more detail, I would like to show you what EDB does with Postgres. So PostgreSQL itself is a relational database management system, just like other relational databases like Oracle or SQL Server. Our version, EDB Postgres, is based on PostgreSQL, which we believe is the best open source database available. So what we do is we take the best of open source PostgreSQL and then we add features and functionality to PostgreSQL to meet the requirements of businesses. So the innovation itself, it starts in the community, and what we get from the community, or everyone gets from the community, it is a very advanced database with many features already included. The benefits of open source include having no vendor lock-in, having a community of thousands of developers, and very fast development cycles. And you might be aware that there's also a large cost benefit of open source software over closed sourced software. Enterprise DB then takes PostgreSQL from the community, and we offer PostgreSQL in an enterprise-ready subscription-based version of Postgres. And the added value for that is, for example, you have 24/7 follow the sun support to keep your developments running and to support your deployments. We have services and training, services to implement and optimize Postgres, and then training to help your team work with Postgres more productively. We also have a product roadmap that you can view and influence. We always like to work with our customers to develop new features. For one example is Resource Manager, which is a tool within EDB Postgres Advanced Server, allowing you to define how much CPU and I/O would be allowed to be used by a reporting process, and how much would be allowed to be used by your regular OLTP workload. We also have enterprise class tool suites for integration, migration, and manageability. And within our EDB Postgres Advanced Server, we have improved performance, better security, and an Oracle compatibility as well. Now let's look at the EDB Postgres platform, which is our offering to you. And it's a database offering, but the important point here is that we want to show you that it's not just a database. If you take a look, you see that there are two database options to choose from. So there's PostgreSQL on the top right, which is a certified version of the community PostgreSQL database. And there's on the left top side, there's EDB Postgres Advanced Server, which is based on PostgreSQL, but has the additional features that I just mentioned of improved performance, enterprise security, and Oracle compatibility, and also some developer and DBA features that you wouldn't have in PostgreSQL itself. So with any subscription, you get what you see here. So you have the tool suites for integration, migration, and management. For management, I'd just like to pick one. For example, EDB Postgres Enterprise Manager, which is a tool that's based on pgadmin, but it has a lot more functionality than just pgadmin to connect to database, manage a database. You have a SQL profiler where you can see what's happening in a database. You have an index advisor based on SQL profiler, or you'd also have some basic performance tuning mechanism like Postgres Expert. Then Postgres, as you can see here in the deployment options section, you can deploy EDB Postgres on bare metal, on many operating systems. We support virtualization, KVM, or containers or VMware. And then we have some various public cloud offerings. We also have a private cloud offering, and then a hybrid solution as well. This all is based or surrounded by services and support. So with our production subscriptions, you get 24/7 global support. We also have a professional services team that can assist you. We provide training as well as certification. So if you're looking into ramping up your staff and getting them certified in Postgres, this is something that we do. And if you need assistance to scale out your database team, we have a remote DBA offer. Let's now look into NoSQL itself. So NoSQL either reads as NoSQL or reads as not only SQL. And the reason for that is, yes, NoSQL is non-relational. So while the relational database management systems are based on tables, rows, and columns, NoSQL is not. So it's a non-relational database or data type. But the reason it's not only SQL is that, yes, we have some databases on the market that do only NoSQL, but then there's other databases, so-called multi-model databases, that mostly have a relational background, but they added NoSQL, so not only SQL, as a capability. And that's also the reason why when we look at NoSQL or not only SQL, the term doesn't describe just one specific technology. It describes different technologies and different architectures. And the reason it was invented or created in the first place was that people were looking to solve challenges that have been created by agile application development and or big data. So in the last slide, I said that SQL adheres to the relational model. So this is, or many of you, I suspect, come from a relational background, because that's what dominated the market for 30 to 40 years, and that's what people are used to. So looking at this, what we do within a relational database, we have tables, and a table has rows and columns. So what you see here, we have 5 tables. The example applies to a book directory, and we see the books table here, but then we have another table for book genres. We have authors, and these are connected, so they are relational. Those tables are in relation to each other. And the benefit of this is that what we do with relational data, we call it to normalize relational data. So information within a relational database should only be stored once. And the way we do that is, okay, every book would only be stored once. That's the case in NoSQL technology as well. But then looking at the authors, if we had a book table in a NoSQL technology, the author would be stored with every book he wrote. So if an author wrote 10 books, the author would be stored 10 times. In this relational example, you will see that the 10 books are stored once each, and then the author would be stored once, and the book authors table to the left would relate the book to the author. So looking at the NoSQL example here, we can see that we have a collection of books, and for every book we have a separate document. Agatha Christie wrote Murder on the Orient Express. This is one document, but I'm sure that Agatha Christie wrote more than one book. So that the benefit here is that we really have all the information about a particular item, in this case about a book. We have this in the same document. But what you also see, if you have more than one book, you would have the information about the author in every single one of those. And on the next slide, we'll see what the pros and cons are. So here we are with the pros and cons. One of the biggest pros is the flexible data model. So when we compare relational databases to NoSQL database or data stores, a relational database, like you saw in the first example, needs a table design, relational design. So beforehand, you need to do planning to create what we call a schema, and that's the definition of how your tables look and how they relate to each other. In NoSQL, however, you don't need to do that. A document, like we've seen in the second example, can hold any type of information. So if you decided you wanted to add more information about a book or just any particular book, it doesn't even have to be information that every book would have. You can just add it to this flexible data field, and the data field is called JSON. So JSON can hold any type of information, and therefore allows developers to add information or to change the information they want to store basically on the fly, and they don't require a DBA to assist them to make changes to the database. A second pro is horizontal scalability, and this will be required for big data. So if you have large amounts of data that you need to store, there are NoSQL technologies out there that allow you to store this data in a very performant way across various servers. While Postgres does not offer sharding yet, if you wanted to leverage the benefits of a NoSQL data store, you can integrate that in EDB Postgres, but we'll see that on one of the next slides. Looking at the cons, the relational databases have been invented about 40 years ago, so they have a good history, a good track record, and they have some benefits that we don't have with NoSQL. So we're lacking all the relational capabilities for structured data. When you have a document, or let's go back to the relational databases. Relational data in a relational database by the name relates to it. So what you can do, you can join data together, and you can see the relation of data within the database and make better use of it. In NoSQL, as it's a non-relational technology, within the technology itself, you can't do joins, you can't relate this data to each other. You would need an external tool to allow you to do that. And this external tool could be EDB Postgres, but we'll see that later. Also, in many of the NoSQL only databases, there's no data verification. So you can't, as the JSON data type takes any type of data, you can't say, okay, this particular field has to be a date, or this particular field has to be a zip code, because there is no particular field. Everything goes into the JSON data type. I spoke about the benefits of a relational database, and one of those benefits is ACID. So ACID is the fundamental basis for working with transactions. So making sure that if you make multiple changes to the database, that all have to be dealt with within one transaction. That's what ACID gives you. But in NoSQL, in NoSQL only databases, we don't have ACID. We have base instead of ACID, and base part of it stands for eventual consistency. So we don't have the type of transactional guarantees that we have with a relational database. We also, those of you who work with relational databases in the past might be aware of multi-version concurrency control, which allows you in a multi-user environment to query data and get data from that particular point in time. So if I run a query now and someone else commits data into the database within the next second, I would still see the type of data, or the data that was valid in the database at the time when I ran my query, and it doesn't get confused with any data that's being committed afterwards. Then many of the NoSQL only data stores have a non-standard query language. So while developers and DBAs, yeah, most of them know SQL very well. SQL is the query language that's used by relational databases, but it's not used by NoSQL only databases. They have their own query language, and this is a might be a pro in a way, but it's a con in another way, because many of the off-the-shelf applications and BI applications, they require a SQL interface to access the data. So that's not a given with NoSQL only databases. So how can you leverage a relational database and the relational benefits with NoSQL? And EDB Postgres can help you in that case, because what EDB Postgres is, it is a traditional relational database, and it has been developed 30 years ago. And at that point in time, we didn't think about the workload of the 21st century. However, when NoSQL has been developed, the Postgres community also decided to implement NoSQL within Postgres. So what they did is they created a data type called JSON. That's the same data type as other NoSQL technologies use. And this makes Postgres a multi-model database. So it does relational, but it also does NoSQL. The benefit of running NoSQL within a relational database is that you get the full ACID compliance. So you can run your data manipulation in documents, but you can run it with the full ACID guarantees. You also have multi-version concurrency control. So when you start a query, it's guaranteed that the output you get is valid at the point in time when you run the query. As it's a multi-model database, you can have structured data, the typical relational data, but you can also have unstructured data. And the benefit of EDB Postgres is that you don't have to make a decision. You don't have to decide you only want relational or you only want non-relational data. They can live together. You can have a table holding relational data, a table holding non-relational data, but you can even have a relational table with an additional JSON data type field for you to add data flexibly. The same background gives you another benefit, which is that you can, even if you decided to start off with unstructured data or flexible data in a JSON data type, and you continue your application development, you will see that normally, what we can tell from experience, you will see that a particular data structure will emerge. And if you wanted to leverage the benefits of a relational database, you could say, I'm going to take out that information from a JSON data field and put that into relational data types, so you can structure your data on the way. And then if you remember the last con, that a NoSQL database doesn't give you a standard query language, with EDB Postgres, EDB Postgres will give you SQL. So if you wanted to access data in NoSQL data field, you can use SQL to query that type of data. Now, what EDB Postgres doesn't give you is the horizontal scalability. So if you need to store big data and you require some type of sharding and the higher the higher horizontal scale out, you might go with a NoSQL only technology if you can accept the base model, so eventual consistency. It doesn't mean that you can't use that data within your enterprise-wide analytics, for example, because what EDB Postgres offers you, we have a tool called the EDB Postgres Data Adapter, and what that does, it connects Postgres to your other databases. For example, if you decide to work with MongoDB, you can use EDB Postgres to connect to those MongoDB databases. And the fear a bit is that we collect a lot of data and we store that data in isolated databases. And what that does, it creates data silos. And the purpose of the EDB Postgres data adapter is to eliminate those data silos, leveraging the benefits of a relational database with sharding technology. As I said, it will give you the horizontal scalability, but the data adapter will then allow you to build a data platform. So you can join data from EDB Postgres with data, for example, from MongoDB. It will give you the SQL interface that I've spoken about earlier. So if you have a BI application or any other application that requires to speak SQL to your application, to your database, then you can use EDB Postgres as an interface to access data, for example, in a MongoDB database. You can also, as we're using SQL, as we in EDB Postgres have the relational background, you can also relate documents to each other, which by itself you wouldn't be able to do in MongoDB. So Mark, with that short introduction, please take us into the demo and show us some of the capabilities of NoSQL with EDB Postgres.
I will show you in this example how JSONB can be used in Postgres 9.5. For the sake of this example, you can see here I've used Postgres Enterprise Manager to display the contents of a database. Postgres Enterprise Manager is our enhanced version of pgadmin. So inside that database, you can see first I created a database called JSONB. Inside JSONB, I've created a schema called example. And then inside that schema called example, there are 7 tables. Notable are the customer table, the customer order line, and the product. So it's a very standard. It's a very standard schema that I've created here. There's nothing special to this data. Inside the customer table, we're working with 3 columns. The ID column, which is going to be the primary key, the name column, which is a JSONB column, and the address column, which is also a JSONB column. So let me now switch over to the standard console. In the standard console, I will go and set my search path to this example, so I don't have to fully qualify all my commands. I will then turn on timing so that we can see how our commands are performing. So let me first give you a little bit more of a detail. Okay, what is inside the customer table? What does it look like? So when we look at the customer table, right, I said before we have 3 columns: the ID column, the name column, the address column. The ID column is going to be my primary key. And my name column is the one that I'm going to work with in this example here. So you can see that I've created an index on the customer primary key, which is a B-tree index, and then I've created check constraints on the first name and on the last name. We're going to use that check constraint to make sure that the data that is entered as part of the JSONB entry actually has data in it, so you can't have anybody entered whose first name and last name are empty. So let me show you here first then what a customer field, a sample customer field, looks like. I'm going to pretty print this this JSONB data element, so you can see here in this sample here my customer ID is cust1, with 5 leading zeros or several leading zeros, and then I'm repeating my customer ID inside the JSONB field. I'll show you in a minute why I'm doing that. And then I have my mandatory entries, the last name and the first name, and then optional entries, title, initial, and postfix. Last name and first name are mandatory because I did create this check constraint here that validates that the first name is not null and the last name is not null. For the sake of this example here, I've created a sample data set with 1,000,000 records, and I'm going to show you now what happens when we do selects first on the primary key, which obviously has a B tree index associated with it. So you can see, because the timing is turned on, that I can do this in 0.7 milliseconds. I'm going to repeat it just to get rid of any kind of vagaries that may happen just because the database may currently be doing something else. But you can see that we're able to do this select in about 0.6 to 0.7 milliseconds most of the time. I'm just going to do it one more time just to give you some data here, and you can see it varies a little bit, but it tends to be in that area. So now I'm going to do the same select, but I'm going to do it based on the JSONB field. So here I'm going to go back to the ID here, and I'm going to search for that same customer. You're going to see here that this is now significantly longer, so we're looking at 400 to 600 times that that time frame. Okay, so what I'm going to do now is I'm going to create an index on this JSONB field. Creating this index will take a few seconds, but as soon as that index has been created, you will see that performance of both queries. Now, whether I use here the select from ID based on the JSONB field, that's going to come down. That's going to come down dramatically now. You're going to see that that is absolutely comparable now to what we're seeing when I run it based on the standard key. So you can see that indexing a standard field, standard SQL field, or indexing a standard a JSONB field results in very, very comparable query performance. So having said that, I'm going to show you the impact of the check constraints that we talked about before, or maybe let me just show you the check constraint one more time here. So I'm going to go describe my table, and just to make sure that we're all on the same page, you can see the check constraint here where I'm making sure that first name is not null and last name is not null. I'm now going to try to do an insert. Excuse me. I'm now going to try to do an insert where I do not have a last name entry, just to show you what happens. And now I get an error message because that new row for that relation failed the check constraint validate customer name. I'm going to show you what happens when I add a data element that does have the a last name. Then it just gets accepted. Okay. So I'm going to show you what that looks like in the pretty print format. So you can see now that I have a new customer in there with ID test2, and the last name, and the name Hans Prince. So what I'm going to do now is I'm going to add more data elements in there. So I'm going to add Hans Prince's title. And you can now see that that Hans Prince is now the Honorable Hans Prince. But I don't really like the Honorable Hans Prince. So what I'm doing is I'm going to update that again. Now you will see here that I'm using the same command both for the initial addition of the field title, right? And then I'm going to use that same command again to update that. So in this case here, this command here, if the field is not there, it will add it. If the field is there, it will update it. So now when I go look at what does my customer look like, now it says His Excellence Prince Hans. Now I still think that for Prince Hans we would like to add more data, and for example I want to add now a subdocument that talks about Prince Hans's contact information. So I will add a document contact with fields fax and cell, and we'll just add that in there, and I will show you what it looks like. So now you can see that I've created a nested document that contains contact information for fax and cell. So now what I'm gonna do is I'm gonna change Prince Hans's contact information. I will change his cell number, and you can see that I can just do that with the JSONB set command, where I indicate the field that I want to change, I indicate the path that I'm going down, and the new value. And I'm just doing that, and then you can see that, okay, now his cell phone number has changed. Okay, now what I'm going to do is I'm going to remove the fax number, and again, that works in a very, very similar way. So I go in there, hey, and I say for the name, the field name, remove everything that is under contact and fax. And you can see there, again, now his fax number is gone. So the important message here is that Postgres 9.5 gives us ample constructs to simply manipulate JSONB data elements. So not only are the JSONB data elements, once properly indexed, just as fast, or almost as fast as standard data elements, they can be completely manipulated with ease and built-in constructs. I'm going to show you another example here where we're going to do some really simple rudimentary analytics on this. So basically what I'm doing is I'm going back to my customer customer field here, and I'm saying, okay, select data elements in there, select the first name, label it properly with uppercase spelling, the last name, label it properly, count how often the first name and the last name were used, and you know, only give me the first top 20 here. This query will take a few seconds because obviously not everything is properly indexed, and we're having a million records in here, but you can see it just comes back as if I had done a standard SQL query. I'll show you a few queries that go that cross the boundary between JSONB and standard SQL. The first query that we're going to run is a query that combines JSONB and conventional data elements. I'm showing you that here on this screen where it is color-coded and properly indented. So basically what I'm doing here is I'm doing a select from my customer table. I'm joining with my customer order. I'm joining that with the customer order line. I'm joining that with the product, and I'm looking for products that were made in New Zealand. So basically my query is going to take the customer data here, which I extract from the JSONB field, and I properly label that with title, first name, last name, the purchase date, which comes from the order, the quantity, which comes from the customer order line, and the product, which comes from the product name. Important here is I'm doing a join that crosses between a JSONB field here, so I'm using the ID on this side, which is JSONB data entry, and on this side here I'm doing it against the standard SQL field. So if I run this query on this side here, we'll see that I get a standard output that just shows me here the title, the first name, the last name, the purchase date, the quantity. So it tells me here, for example, that Mr. Hans Brown on Friday, May 27th bought 13 yellow products from New Zealand. So the important element here is I can easily create queries that cross the boundary between JSONB and standard SQL. In fact, in Postgres, there really is no boundary between those two things. There, JSONB is a first-class data type. So let's do something that's a bit more complex here. So what I'm doing here is, again, I'm showing you how you can go back and forth between a JSONB data element and standard SQL. So here, what I'm going to do is I'm going to use entirely the customer. where I'm getting data about the title, the first name, the initial, last name, postfix, etc. And as you remember, all of those are a JSONB data element. Plus, I'm using here the join lateral. So really, I'm joining the customer table with itself, so I can do an operation on the customer table, which is convert the JSONB to record. Okay, I'm getting it out of the name field, and I'm saying here, get me the values for ID, title, initial, postfix, etc. Get me those as the following data types. Label them this way. Bring them up here, and here I'm relabeling them, so that at the end of the day, I get a very simple output that looks exactly like a standard SQL output, but it comes from a JSONB field. Okay, so again, this conversion here between JSONB and standard SQL is absolutely straightforward in Postgres 9.5. Let me show it to you the other way around. So I'm going to take a much simpler query here, where I convert what is now in JSON, right? Where I convert what is a standard SQL field out of my customer order, and I make that look like a JSON field. So basically here, all I did is I took my order IDs, my customer IDs, my order date, and I just converted that to JSON. So if your program is looking for JSON data, then you can easily use it this way. So in summary, I think this demo should have shown you that that you can index JSONB data elements just like you can index standard SQL entries, that the performance of both is absolutely comparable. You can create constraints and check constraints on JSONB fields to make sure that you have data integrity even with JSONB. You can easily bridge between JSONB and standard data elements, both back and forth. Okay, so there's a total compatibility between both data types. In fact, JSONB in Postgres is a first order data element. Thank you.
Okay, thank you. So that was Mark's demo. And as I promised in the beginning, I would like to summarize what we've seen today. I've spoken about it, and Mark has shown you that EDB Postgres is a relational database, but it also has the NoSQL capability. With EDB Postgres, you would be using the benefits and the reliability of relational database management systems, still having the schemaless flexibility of NoSQL. So that's established using the JSON data type. With relational and non-relational database within one database, you have the possibility to use structured, unstructured, and semi-structured data in the same database. It is highly scalable, and if you wanted to be even more scalable, you could use a NoSQL data store, accepting some of the disadvantages for the very big advantage of being highly horizontal scalable. And if you decided to do that, you don't have to give up on all the benefits of a relational database. If you wanted to leverage those, then you could use the EDB Postgres data adapter to allow the integration of a NoSQL only technology into your EDB Postgres solution. Last, I would like to share some resources with you. So we have a NoSQL datasheet where you can get a good overview of what I've presented today. Then on the PostgreSQL community website, there's a JSON documentation available. You will see that it was added a couple of versions ago, and now in PostgreSQL 9.5, there are plenty of functions available for JSON. So if you are interested in what else it can do, what Mark didn't show you, you can look at that documentation. And always, if you have any questions, please feel free to contact us. Thank you for attending today. This is the end of the presentation.